A hummingbird lives maybe 5 years. You'll probably live 80. But according to a 2013 study in animal behavior, the hummingbird experiences more conscious moments per second than you ever will, meaning its 5 years contain more lived life than your 80. That fact gets stranger the deeper you go. By the end of this video, you'll know what time actually feels like at 10 different speeds, including one where it stops completely. By minute 11, a particle at CERN will prove that time physically stretched to 29 times its normal length, measured, confirmed with only 0.2% error. To understand why the hummingbird wins, the narrator must first go somewhere slower, much slower, down to the level of muscle and mucus, where the world is not a blur of wings but a long, patient conversation between a body and the ground beneath it. This is where time begins, not with speed but with texture. But that is not even the strangest part. In 2021, a team publishing in the Journal of Zoology set a snail on sandpaper, not to be cruel, to answer a question that had nagged biologists for decades. What actually controls how fast a snail moves? Body size, most assumed. Larger animal, longer stride, faster pace. The answer turned out to be something no one expected. The grain of the sandpaper beneath the snail's foot was the controlling variable, not the snail's body size at all. Coarser texture, slower snail. Finer texture, faster snail. Body size had zero measurable effect on speed whatsoever. The snail is not limited by what it is. It is limited entirely by what it touches. That finding reframes the entire bottom of the speed ladder. A snail crawling at 0.03 miles per hour is not a failure of biology. It is a precise mechanical response to surface friction. Its nervous system, its mucus layer, its muscular foot wave, all are perfectly calibrated. The snail is not slow. It is optimized for a world measured in millimeters. Now consider what the snail perceives while it moves. This is where the hidden thread of this video begins to appear. Perception speed, the rate at which an animal processes new visual information, varies enormously across species. For the snail, the world updates slowly. For the hummingbird at the top of the opening, it updates at an almost painful rate. What happens at the next level is what most biology textbooks get completely wrong. In a moment, a starfish will prove that some creatures are not just slow. They are essentially frozen inside their own perception of reality. The crown-of-thorns starfish is not a gentle creature. It crawls across coral reefs in the Indo-Pacific and devours living coral polyps, leaving white skeletal rubble in its wake. It can devastate entire reef systems, but inside its own experience of time, it is barely moving through a world that barely moves. Its critical flicker fusion rate, the speed at which it can register visual changes, sits at just 0.7 Hz. 0.7 Hz means fewer than one visual update per second. A human brain processes roughly 60 visual changes per second. The starfish processes the same physical world at less than 1/60th of that rate. When a human walks past a coral reef, the starfish does not see a person. It sees a slow smear of color and pressure, a rumor of movement arriving long after the movement is gone. This is the starfish blur, and it is not a defect. For an animal that feeds on stationary coral and has no predators fast enough to require rapid response, perceiving fewer than one visual change per second is an entirely adequate relationship with reality. The starfish is not missing the world. It is experiencing a different version of it entirely. The critical flicker fusion rate is the measurement that makes this concrete. It is the frequency at which a flickering light appears to fuse into a steady beam, a direct measure of how fast the nervous system samples incoming visual data. Flies test at over 200 Hz, humans at roughly 60. The crown-of-thorns starfish at 0.7. That is not a difference in degree. That is a difference in the nature of experienced reality. This is the hidden variable the video has been building toward. Not muscle strength, not body size, not metabolic rate alone, but perception speed. The rate at which an organism carves the continuous flow of the physical world into discrete, processable moments. Everything that follows is about that rate, climbing higher and higher until physics itself becomes the limit. But the climb is about to get violent. What comes next involves 120 watts per kilogram and a hunt that ends in under 6 seconds. The cheetah is the fastest land animal on Earth, and that fact obscures something far more interesting. Wild GPS-tracked cheetahs in Botswana's Okavango Delta were fitted with accelerometers in a landmark study and found to generate 120 watts of power per kilogram of body weight during a sprint. That is nearly 4 times the output of Usain Bolt during his world record 100-meter run. It is double the output of a greyhound. But here is what the Okavango data revealed that no laboratory study could have found. Professor Alan Wilson and his team tracked 5 wild cheetahs for 17 months using GPS collars precise enough to reconstruct individual hunts in full spatial detail. They expected top speed to predict success. They were wrong. It was grip and maneuverability, not top speed, that determined whether a hunt succeeded or failed. A cheetah accelerating at full capacity through an open stretch was less likely to secure the kill than one that had matched the prey's direction change within a fraction of a second at lower speed. The cheetah's body is not optimized for straight-line velocity. It is optimized for the ability to read, predict, and match movement in real time. That requires perception speed. A cheetah that cannot process its prey's direction change faster than the prey initiates, it is always one step behind. The cheetah's flicker fusion rate is not published in isolation, but its visual acuity and reaction time data confirm a nervous system tuned to resolve rapid motion with precision. The grip wins the hunt, but the perception is what makes the grip possible. Now the narrator moves upward, away from the savanna into the air, where the demands on perception become structurally different. Flying animals do not just need to be fast. They need to see fast because at altitude, a miscalculation of even a few milliseconds is not a missed meal. It is a wall. It is a branch. It is the ground. A 2026 study in Nature Ecology and Evolution examined 237 species and found something that reframes the entire evolutionary history of flight. Flying animals have critical flicker fusion rates roughly twice as high as non-flying animals of comparable body size. This is the double-speed flyer's finding, and it means flight did not just demand speed of movement. It demanded, and actively evolved, a faster perception of time itself. A dragonfly hunting over a pond's surface is running its visual system at frequencies that would be neurologically exhausting for a mammal of the same mass. It is not simply moving fast. It is living inside a version of the world that updates twice as often as the world experienced by an animal that stays on the ground. Evolution did not just shape the wing. It shaped the clock behind the eye. The next level is where the human nervous system reaches its limit. There is a creature whose perception speed makes the dragonfly look leisurely, a mantis shrimp that processes polarized light across 16 color channels, whose strike moves at 23 meters per second, faster than a rifle bullet in water. But before reaching it, one fact must be established that changes everything that follows. The mantis shrimp's speed is not the point. The point is what Kevin Healy said in 2013, that the ability to perceive time on very small scales, fractions of a second, may be the difference between life and death. That is not a metaphor. That is a measured, documented survival mechanism. And what comes at minute 11 will show what happens when that mechanism operates not at the biological limit, but at the physical one. The mantis shrimp, Odontodactylus scilaris, strikes its prey with a club-like appendage that accelerates faster than a .22 caliber bullet. The strike lasts less than 3 milliseconds. The animal must initiate, aim, and commit to that strike based on visual information processed before the target has time to respond. At this level of biology, perception speed is not an advantage. It is the only mechanism that makes the behavior physically possible at all. Every level climbed so far has been biological. Muscle, mucus, nerve, fiber, photoreceptor. But biology has a ceiling. The metabolic rate of even the fastest-brained insect eventually runs into the cost of running that brain, the caloric price of perception. There is a reason no organism evolves to process the world at 1000 Hz. The energy expenditure would be catastrophic. Nature finds the minimum viable perception speed for survival, then stops. This is why the metabolic time finding from the 2013 Animal Behavior Study is so precise in what it claims. It does not say the hummingbird is smarter or more aware. It says the hummingbird perceives more information per second, more distinct moments, than a tortoise does. A tortoise living 200 years experiences subjectively fewer discrete moments of life than a hummingbird that dies at 5. The hummingbird's 5 years contain more lived life, because its nervous system subdivides time more finely. That is an extraordinary thing to sit with. Two creatures alive on the same planet, breathing the same air, experiencing what an outside observer would call the same Tuesday afternoon. And one of them is receiving approximately 1 frame per several seconds while the other is receiving 60 or more. They are not sharing the same Tuesday. They are inhabiting different versions of time. The narrator pauses here to name what has been built. 10 levels of speed exist in this video, and the thread connecting them is not muscle mass or body weight. It is the sampling rate of the nervous system, the number of distinct moments carved out of continuous physical reality per second. A snail samples the world slowly and moves accordingly. A hummingbird samples it rapidly and burns through calories accordingly. A cheetah samples it precisely and wins hunts accordingly. Speed is not motion. Speed is resolution. Now comes the level where biology ends and physics begins, where the limit is no longer caloric cost or neural architecture, but the geometry of spacetime itself. To reach it, the narrator must go to Geneva, Switzerland, to a circular tunnel 27 kilometers in circumference buried 100 meters beneath the ground, to the place where in 1977 a team of physicists did something that should not have been possible and measured it anyway. What they found in that tunnel changed what the word time is allowed to mean. Muons are subatomic particles produced when cosmic rays strike the upper atmosphere. They are unstable. Their mean lifetime, measured in a laboratory at rest, is approximately 2.2 microseconds. At that decay rate, a muon produced 15 kilometers above the Earth's surface at nearly the speed of light should decay long before reaching the ground. And yet, cosmic ray muons reach the surface constantly. This anomaly was the first signal that time was not behaving as expected. In 1977, at CERN, a team built the muon storage ring, a device that accelerated muons to a velocity corresponding to a Lorentz factor, gamma, of 29.33. That number is not incidental. Gamma of 29.33 means the muon is traveling at a speed where special relativity predicts its internal clock runs 29.33 times slower than a stationary clock. It means a muon that should live 2.2 microseconds should, at this speed, appear to live 64.4 microseconds as measured by laboratory instruments. Team measured 64.419 microseconds. The prediction from special relativity was 64.435 microseconds. The discrepancy was 0.2%, not a rounding error, a confirmation. Time dilation is not a theoretical convenience or a mathematical artifact. It is a physical phenomenon measurable to sub-percent precision using real particles in a real tunnel in real time. The muon's clock ran slow because the muon was moving fast. That is not a metaphor, that is a measurement. The muon clock proof is the top of the ladder. Every previous level in this video, snail to starfish to cheetah to dragonfly to mantis shrimp to hummingbird, was about the biological rate at which an organism samples reality. The muon introduces something different. At gamma 29.33, time itself is physically dilated. The muon does not perceive the world faster. Time around the muon is genuinely, measurably slower relative to the laboratory frame. It is not a nervous system effect, it is a spacetime effect. This distinction matters because it closes the loop on the question the hummingbird opened. The hummingbird experiences more moments per second because its nervous system samples incoming data more frequently. The muon experiences more elapsed time per second because spacetime itself has stretched around it. These are two different mechanisms arriving at the same structural truth. The rate at which time passes is not fixed. It depends on the observer. It depends on the speed. Step back now and lay all 10 levels side by side. A snail, controlled entirely by surface texture, moving at a pace where a single human step is an event of geological significance. A starfish at 0.7 visual updates per second, frozen in a perpetual amber of slow perception. A tortoise outliving human timescales, but experiencing fewer subjective moments than the hummingbird it outlives by a century and a half. A cheetah burning 120 watts per kilogram, 4 times Usain Bolt, not to run fast but to turn precisely. A dragonfly whose flight evolved alongside a perception rate twice that of any non-flying animal. A mantis shrimp completing a lethal strike in under 3 milliseconds. The hummingbird itself, processing the world at a rate that compresses more life into 5 years than most large mammals experience in decades. And then CERN, the tunnel under Geneva where a particle proved that time is not a backdrop, but a variable measurable in microseconds, confirmable to 0.2%. The reveal is 30 seconds away. The thread the viewer has been following without knowing it is now visible. Every level was about the same question. How fast does a given entity carve continuous reality into discrete, experienceable moments? For some organisms, biology sets that rate. For particles near the speed of light, physics sets it, and physics is more ruthless than biology. At gamma 29.33, the muon is not perceiving faster. Time around it is literally running slower. Perception and physics converge on the same answer from opposite directions. Here is what it all means. Speed is not motion. It is the rate at which an entity, biological or subatomic, experiences reality itself. A starfish frozen at 0.7 frames per second, and a muon at CERN living 29 times longer than physics said it should are not opposites. They are the two ends of a single axis. The hummingbird is somewhere in the middle, burning through 5 years of life that contain more conscious moments than 80 years of a slower existence. Time is not something that happens to you. It is something you generate at whatever rate your nature allows. The question worth leaving with, which end of the axis are you closer to?